Have you ever looked around nature and saw beautiful patterns and symmetries? Did you know that these patterns are associated with sequences of numbers? What's up, guys? It's Alan East, and I'll be sharing with you 5 stunning ways that math exists in nature. Let's get started. Have you ever heard of the Fibonacci sequence? Named after the famous mathematician Leonardo Fibonacci, this number sequence is a simple yet profound pattern. The sequence begins with the numbers 1 and 1, and then each subsequent number is found by adding the 2 previous numbers. What's remarkable is that the numbers in the sequence are often seen in nature. A few examples include the number of spirals in a pine cone, pineapple, or seeds in a sunflower, or the number of petals on a flower. The numbers in this sequence also form a unique shape known as the Fibonacci spiral, which again we see in the nature in the form of shells and the shape of hurricanes. Next, we have fractals in nature. What do mountains, broccoli, and the stock market have in common? The answer to that question may best be explained by fractals. So, fractals are another intriguing mathematical shape that we see in nature. A fractal is self-similar across different scales, meaning the same basic shape is seen again and again in the shape itself like a never-ending pattern. Fractals are common in nature and are found nearly everywhere, like trees, rivers, coastlines, mountains, clouds, seashells, hurricanes, broccoli, etc. Like, for example, every branch of broccoli looks just like its parent stalk. The surface of the lining of our lungs has a fractal pattern that allows for more oxygen to be absorbed. Such complex, real-world processes can be expressed in equations through fractal geometry. Even to the everyday person, fractals are generally interesting to look at, even if you don't understand what a fractal is. But to a mathematician, it is a complex subject area. Fractals are so much more important to us than we think because they help us study and understand important scientific concepts such as the patterns in snowflakes and brainwaves, or the way bacteria grows. Another example that shows a connection between nature and math is the concentric circles in nature. Concentric refers to the circles that share the same center but have different radii. This means the circles are all different sizes, one inside the other. A common example is in the ripples of a pond when something hits the surface of the water, but we also see concentric circles in the layers of an onion and the rings of trees that form as it grows and ages. If you live near woods, you might go looking for a fallen tree to count the rings, or look for an orb spider web, which is built with nearly perfect concentric circles. Next up, we have hexagons in nature. A regular hexagon has 6 sides of equal length, and this shape is seen again and again in the world around us. The most common example of nature using hexagons is in a beehive. Well, as it turns out, it really is all about math. A hexagon is the shape that best fills a plane with equal size units and leaves no wasted space. Hexagonal packing also minimizes the perimeter for a given area because of its 120-degree angles. With this structure, the pull of surface tension in each direction is most mechanically stable, which is why, even though bees make their honeycombs with circular units, the end result when the wax hardens into place is hexagonal. Mathematics in nature doesn't just exist on planet Earth, but beyond, we can see mathematical features in outer space. For instance, the shape of our galaxy is a Fibonacci spiral, and concentric circles in the rings of Saturn. In addition, we can also see a unique symmetric event in outer space, a unique phenomenon that exists between the Earth, Moon, and Sun that makes a solar eclipse possible. Every 2 years, the Moon passes between the Sun and the Earth in such a way that it appears to completely cover the Sun. But how is this possible when the Moon is so much smaller than the Sun? Because of math. You see, the Moon is approximately 400 times smaller than the Sun, but it is also approximately 400 times further away. This symmetry allows for a total solar eclipse that doesn't seem to happen on any other planet. How amazing this relationship between mathematics and nature is. Almost everything in our world, or should I say the universe, can be connected to math. Comment down below on how or what ways you see math in nature. And I guess that's it for now. I hope you guys were as fascinated with this subject as I was. Until next time, thanks for watching.